So at the bottom of the home page, in the lower left of the site, is a little link labeled Excel data. So when you get a chance, download that. Let me see if that works on my machine. Yeah. So click on that and it should download the file. Use UKZN did.xlsx. It's also under course materials under the session. So from the data stream website, in the lower left corner, you'll see a link for Excel data. Download that, get the file open on your machine, and then we'll get started. It's also under the course materials under data types and sources, session 3. But technically, this is a non-existing session on day 3 that will take the place of trends and causality, but if we have time later, I don't have a lot on that, but if we have time later, we can go into that. But we want to get you started to work on stuff, get analysis going. So everyone should have a file that looks like this. It's actual data from UKZN. I've taken off the student IDs. I've de-identified it, so we're kosher. As you can see, it's got these columns for the student's gender, their race, their age, the college in which their qualification is, their qualification, both external and internal, that's pretty detailed. Their year of study, which never mind that because everyone has the same value, so you're not gonna, that's not a variable, that's a constant in this data set. Everyone is first year. Then it has their matriculation points. Some people it's missing. Their weighted average marks for the year, the number of credits they enrolled, the number of credits they passed, and the percent they passed. Then it's got these binary indicators that tell you whether they came back in the same qualification, that's reg same, whether they came back in a different qualification, that's reg diff, and then the sum of those two, whether they returned at all. Then exclusions are people who are kicked out, as I understand. Dropout, and the total of those two, the people who did not return. So that's the data set. Okay, any questions on that? So what I'm going to do is show you tables, which some of you said you have some experience with, others haven't used. My goal here is kind of to give you the basic ideas, because this technology, this metaphor, this way of analyzing data is becoming more and more popular, both in Excel, but in other packages as well, because it's based on what's called a data cube, where you have all the variables, and you can pick the variables, put them in your rows, put them in your columns, nest them in your columns, nest them in your rows, and it can get really powerful. A more advanced package of this called Power Pivot, which allow you to deploy your pivot tables on the web, do a bunch of other things, connect to all sorts of data and so on. So with your cursor anywhere in the database, just as long as it knows anywhere within the sea of data, from the insert menu, and probably good if I get my menus to stick. So I'll keep my menus out. So from the insert menu on the left, you'll see there's a couple of things related to tables. Pivot table, recommended pivot tables, table, illustration, but we're interested in the pivot table. So go to the upper left-hand corner and click on it once. And it then starts the dialog for creating a pivot table. And usually, it's set just like you need it. But what its features include is, what data do you want me to analyze? And it defaults to the data file it recognizes. And as long as there are continuous rows and columns without a stop, it'll recognize the right thing. Now, in this case, it's saying it's going from A1 to R8231. So there are 8,230 records of data going from columns A through R. And of course, that could be changed. You could also actually do a pivot table and link to external databases. You don't have to have the data in Excel. if they're in any relational database, like if you work in Access, if you work in MySQL, if you work in SQL Server, all Aquadata Studio, all those packages in which you create a view of database data, you can actually access it through the pivot tables. It then asks you where you want to put it, and the default is a new worksheet, so it'll create a new tab. But you can put it in the same tab. You can put pivot tables wherever you want as long as you're still in Excel, and in the same spreadsheet. So either existing. So it's set to the way we want. So if we click OK, we'll get a new tab. So it added a sheet 2, and it gives us the palette for the pivot table. This is where we get to do our artistry. We get to create our pictures of data. You'll also notice, let's see if it increases that, but it doesn't increase on the right. This is your work area. Now, not everyone always gets that open because there is a way to actually close that. I'm not going to do it now. And then you have to find it, and I've never closed it, so I don't know actually what tab it is you get it back in. But that shows you the fields you're dealing with, lists them, and it allows you to use those fields as filters, which means it's a page variable. And it'll give you a pop-down, and you can change the contents of the pivot table by selecting from the pop-down. It allows you to put it in the rows, the columns, or the cells. So as a row or a column variable, it's going to be the value. So like you would not want to put like age necessarily in a column variable, because if it's individual ages, it'll look something like this, and it'll give you all the ages of every student, the different ages that students are. Now that's actually okay because we'll group them later into a collapsed variable, but for now, I just want to show you that's why continuous variables typically, I'll just take it out here, throw it away, are not used. But let's say we want to look at the students by, so let's start with gender distribution. So let's say we take the gender variable, click on it and drag it and put it into the rows box. So I grabbed gender from the list up here, and I clicked and I dragged it and I dropped it into the rows box. So it now appears in the rows. We all got that? Anyone need a hand from anyone? Okay, the insert of the pivot table. So we go to the insert menu, pivot table, and click OK. And now you can click and drag gender into the rows box. Okay? Huh. Your gender is 01. Okay. Oh, you know what? That was I accidentally loaded the SPSS file instead of the Excel file, or the file that was preparing. So, if you get 01, instead of what I have, then what you can do is under 0, you can type male. And under 1, you could type female. No, it's okay. It just means they're going to all have the codes there. So once you type it, those labels will be there forever whenever you use that variable. Now, I'm backwards. My female's on top, your male should be on top. You can always change that, because if you don't like where a value is, you can grab it and move it to a different place. So that's all flexible. So hopefully we all have a female, male, or at worst we have 0, 1 for our genders, where 0 is male and 1 is female. Now when we want to simply count how many are in each group, we can use any variable, because we're just going to do a count on it. But sometimes if you use a numeric variable, it'll default to sum. So if you had a 0, 1 variable like gender, and if you click and dragged it and put it in values, yours might be sum of gender. Whereas mine, it will be a count because mine's already a text variable and it doesn't know what to do with text except count it. It doesn't matter what it is because once you get values in there, you can right-click on one of those values. So let's say I take the top value and I right-click. And down that menu is a Summarize Values By sub-menu. And yours may be sum, and you can change it to count. Okay, what I just simply did was, I just took gender again as a variable, and I clicked and dragged it and put it in values. And mine worked because mine are text, but yours will go sum of gender. You want to change it to count of gender. And generally speaking, these right-click menus will allow you to make all the changes you want on a pivot table. So I can click on that, summarize values by, and change it from sum to count. Okay? Now, do the exact same thing again. Take gender once more, put it in values, and create yet a second version of it. And for you, change that to a count. Summarize values by count. So you should have 2 counts of gender. Is everyone caught up to that? No? Okay. Whoops. Okay, you need the pivot table. So insert, from the insert menu, pivot table, all the way on the left. Click OK. Take gender, click and drag it down to rows. We'll fix it in a second. Okay, and now take gender again from the top. Put it into values. Click and drag it, put it into values. And do it one more time. Yeah, we're going to have 3 of them. We just keep putting gender in. It just doesn't really matter what variable, but you guys have the student ID. Okay. I definitely put the wrong file there. Yeah, under values. Now, right-click on the first 0. Get onto the 0. Click on it, left-click on it. Okay, now right-click on it. And choose Show Values As, and make it, Summarize Values By, Count. And do the same for the other one. Okay. Yeah. Yeah. Yeah, you have to do it on the actual number, not on the label of it. Yeah. Huh. No, it's not calculated field. Let me see. Oh, I didn't. I created a field I didn't want to do. Whoops. Well, we won't worry about that. Okay. What's the right click? Okay. Huh. So that doesn't do it. It has to go to field settings.
Oh, yeah, it does it, yeah.
Yeah, yeah.
Yeah.
Yep.
Found it.
Yeah. Okay, right click on the number. Right click. Okay. Summarize values by. Change that to count. Because it was summing the zeros and it was summing the ones. Put another one of those gender variables in and change it to count. Well, actually, you already had a pivot table in there? That's probably, this is exactly where I'm going, but go to sheet 1. Okay, you don't have one in, so go back to the data. insert, whoops, sorry, my bad, insert pivot table. Yeah. And now click OK. And now you have the blank palette, and you can put gender in the rows, and put gender in the, oh, it already has it there from when you did that. And you can right-click on the 0, summarize by, count. You can do that a second time, put another version of gender in there. The reason I did this was to show you one of the powerful features. It'll drive you crazy, but it's a powerful feature. Let's say I want to change the second one to percent of column total, so that I have the number and I have the percent. If I right-click on it, and right below summarize values by is show values as. And that's where I can choose to have it as a percent of the row, the column, the grand total, and so on. So the one I want is percent of column total, which is up here. And so if I select that, and even if I didn't add another gender, I could just do that to the gender I have, and it gives me percent of column total. I might be a stickler about my levels of precision and not want to see 2 decimal places. As with everything, if you want to change the way something looks, you click on it, click on a number, and there is a Format Cells option. And I can use that. It comes up and tells me, okay, right now this is formatted as a percentage with 2 decimal places, and I can change it to whatever I want. I could get rid of a decimal place by typing in 1 or clicking on the down button. And I have, didn't do it right. It only did it to the 1 number format. Oh, not format cells. I apologize. My bad. If you do format cells, it'll only format that one cell. But if you change the number format, which is the choice below format cells, number format, that's when it'll apply it to every occurrence and not just that one cell. It'll change all the cells. So that's kind of the basics of doing a simple crosstab. How you can have numbers, you could have percentages. But of course, where this takes you in new places, is let's say you wanted to look at a gender and race at the same time. You could take the race variable and drag it into the columns box, and you could either put it above or below the sigma values that appears there. If I put it below, I'll get all the numbers for each race, and the race label is to the left of the cell, so it's a lot great for the first cell. So I can do it. Testing. Okay. I get all the numbers and then all the percentages. If I place race above values, it gives me the number and percentage for the first race, the number and percentage for the second race, the number and percentage for the third race. Huh? Sure. I'll get back to the beginning on that. So now I have this table with just the gender breakdown. I want to add a race breakdown. So I'll click and drag race and put it into my columns box. There's already something in my columns box. If I have the number and the percent, it's the sigma values icon. So whether I drop race above or below that will determine whether the table looks like this, where it's race within number and percent, or if it's above, it'll look like this with the number and the percent for each race. Because it's Whatever is below is what's nested within whatever's above. But I'd probably want to look at race the other way, where race is the rows and sex is the columns, so I could swap them. Just click and drag, put race where gender is, and that temporarily gives me this. And I could put gender where race is, and then it turns it like that. That's why this is called a pivot table. I could play. I can even move where the values are and put them in my rows rather than my columns. So you have control, total control. You can get it to look the way you want to look. Now I'm going to go back to this view, because you'll see now those percentages are giving me, well, let's get it back. I have it the wrong way. Gender and race. So let's say I want to put them both in the columns and do the nested approach, and I want to look at, say, gender within race. So I put race over gender, and now you'll notice that the percentages are of the grand column total, not within group. If I wanted to see the gender breakdown within group, this doesn't give it to me. This gives me, says 42% of all students are female African. 30% are male African. Now here's where an Apple and a PC differ. One of the commands, and this is sort of an advanced command, this is about as confusing as these things get. And you can't do it if you have an Apple. But one of the show values as choices are percent of parent row and percent of parent column. Now here's why it's completely unintuitive. Whereas we're looking at the numbers as a percent of the column total, to get the percent within group, we have to do it as percent of parent row. I know, it just doesn't seem quite right, but then you think of it, it's that row total you want to get. It's for that row within that column, so it's the parent row within the column. And again, this isn't available on the Apple, so if I said percent of parent row total, then it's showing me that females are 58.4% of Africans, Africans are 72% of the total. Indian males are 38.3% of Indians, and Indians are 22.8% of the total.
How can we fix that back?
Yeah, with Apple, you basically either have to switch one to the columns and then do percent of the row total. So another way I could have done this is if I had gender in rows, and in fact, I'm going to get rid of my, oops, I did the wrong one. Let's do this. So let's say I was back to my numbers and I wanted to look at my percentage within both ways. Well, if I show this as percent of row total, I'm getting the gender distribution. And if I add another version of gender and do it percent of column total, I'll get the other percent. Anyway, as you can see, there are just so many ways you could do this. Let me get back to where you hopefully were or are. I'm going to get back to the case where I've got 2, and this one I will show as percent of column total. I'm just going to do like one more thing, and I'm just going to let you play, and I'm going to go around and help you out as you're playing, seeing what you're trying to do. So if I switch this to summarize, show values as percent of parent row, this is where I was, except my number format. number format. And I'm going to go down to 0 decimals. So now I've got, looks clean. Let's say I wanted to see this by college. Now, I don't know what your college values are. They may be 1, 2, 3, 4, as opposed to mine in this data, and I'll upload the other data set so it has more labels for you to play with. Mine, I have AES, well, actually have it spelled out. Agricultural Engineering Science, Health Humanities, Law and Management Studies. Those, my values look like that. Your values may look like 1, 2, 3, 4. Oh, I have to go back. I'm going to show you one other cool thing before I go. This you don't have to do. Let's say I had it done this way, and I wanted to change my race labels. If I type African, if I can type, over the 1, even if it's nested, it'll change the values in the other nested group. So this is like, it's affecting the variable at the top level. And if I go away and come back tomorrow with this, it'll still have those labels in it. It's adding it to the database. I can even create a new field, and it gets added to the database. So I'm just going to show you a few other, 2 other features of this. The first is, as I said, I have a filter, what's called a filter variable or a page variable. So this is for the entire institution. Let me get it back to the other way so we get the proper. I can look at it only for agricultural engineering sciences by using that pop down from whatever variables in the filter menu, in the filter space. So that's for agricultural and engineering science. There's for health sciences, and so on, for humanities. And then you'll see there's a box, select multiple items, and then it puts check boxes, and I can look at health sciences and humanities together. Why I would want to do that, I have no idea. So that popping filter menu, you can either select single values or you can select multiple values. Okay, couple of other features. I'm going to get rid of race, get rid of gender. Now I'm going to look at, with age, my variable is every single age. So I put age in the rows. Well, that's not very useful, but I can also see the distribution. I got very few people who are 18 or under. I got a bunch, like half, who are 19, because this is new students only. And then I got a relatively few. So I might want to do something like take the 16s, 17s, and 18s and make them one group. So I can highlight the values in the rows, right-click, and group it. And I'll put them together. And that would be the group 18 or younger. And then I might want to take I'll leave my 19 as it is. I'll take my 20 through 22 and group them. It's a little awkward because it does that weird hierarchical. I just have to make sure I get from the value 20 to the value 22 in the sub column. Group them, 20 to 22. And then I'm going to take everybody else and make them 23 and older. Well, I don't have to make them 23 and older. They already are. Group them and call that 23 plus. So now what happened is I have 2 variables in my row box down here, age and age 2. Age 2 is the new variable I created. I can get rid of the old variable age by clicking and dragging it off the sheet, and now I have my grouped age variable. So I grouped the values, got rid of the original variable, and boom, I've got the new variable, And that variable is now part of this data. If I take it out, get rid of it. If I get rid of it now, if I go down to the bottom of my list, there it is, age 2. I could put it back in. This is just the tip of the iceberg of what you can do with pivot tables. And as you can see, it can get complicated, but the core ideas are simple. Rows, columns, nested values, page filters. And you can show the data like things like, I guess I should show this. Let me get rid of our counts. And let's see what the average weight, the matriculation points by age look like. I could take my mat points, put it in values, right-click, and summarize by average. And now I've got the average matric points. Let me format that so it's just got 1 decimal place, number with 1, whoops, not 5, not 4, 1 decimal place. So now I can see my younger students are my higher matric point students, and my older students are my lower matric point students. So I can show an average. Let's see how that holds up for weighted marks. I'll put that in, and I also will summarize by average and change the format to a number with 1 decimal place. And it holds up. My younger students get higher average weighted marks and my older students get lower average weighted marks. I can't, in Excel, I'm not looking at, is that statistically significant? I'd have to run a statistical analysis using SPSS or Stata or SAS, but it's a great way to generate tables. I usually take the content of the table, copy it, and paste it somewhere else, and then format it for the way I want it to look. So I would take like this, and I'd copy it. I'd go to a new sheet or a new space and paste it. Usually I'll paste it as values. If I pasted it as just a straight paste, it would look like that, which isn't bad actually, because it kept the formatting, which is actually pretty good. Because then I can always go to my home menu. Where is that? Or is it my, this is Excel, where's the design? Format as table, and I could pick a look for it. The only thing I don't like about the formatting as table, it generally makes it look okay, except why it's doing white print on a blue background. I can't tell, I don't know, maybe because that was there originally. The only thing I don't like is it always throws the filters in, the little down, these things, which I find annoying, but you can always turn them off over here in the sort and filter. And of course, you could change your labels to be different. And then finally, I keep thinking of a finally, and then I think of something else. I must show them. If I have my cursor in my pivot table, and I insert a pivot chart, actually, I can even just insert a chart. What are you recommending I insert? You think I should do a clustered column? Okay. And I get a pivot chart. And a pivot chart lets me change the filtering values. So I can change it right there in the chart. Oh, there were some ages that didn't get grouped because when I was grouping, I only had certain colleges selected. That's a problem with grouping. You got to make sure you've got all your data there when you group, or else like here, you'll find a few ages that weren't thrown in. And I could throw them in by regrouping, but I'm just trying to give you a feel for what this is like. I don't often do that because I like to get the data like I want, and then I do a chart off the other data, the copy of the data, because then I have more control as to what I probably don't want the total in there. And then I have a lot more control. You know, it's linked to the data, the values, but I can't change the nesting or select a different group or what have you with the chart, which I can do. So there are any questions about this? Anything else you wonder if it can do or you want it to do? Otherwise, I just think you can play with it for a few minutes. Just try different things. I'll come around, and if you blow it up, no problem. Just close it, start again. I probably use PivotTables for half of my analyses, because often I'm just doing descriptive stuff. I just want to create a chart or a table. And PivotTables are a quick way to take data, create charts, analyze it. Let's look at the persistence rate by gender by college. Okay. I guess I got to do that on the pivot table. I could take out these. Let me get rid of age. Let me put gender back in. And look at my percent, the return. The return is a 0-1 variable. So if I sum it, I'm going to get the number of females and the number of males who returned. But if I take the average, I'm going to get the proportion of males and females who returned. So the average of the return variable, and then I can make it a percent. Oh, that just did the cell. I need to do number format to get them both to change. Make it a percent with 1 decimal place. And I have my retention rate by male, female for all colleges. If I take my college variable and I bring it down, move my gender to the columns, and now I'm seeing for each college the overall return rate on the right and the gender breakdown of that retention rate in the body. So there's 2 types of variables you're dealing with in pivot tables: a categorical variable and a continuous interval ratio variable. The categorical variables typically are your rows and your columns. Except you can throw them in the values, but then that's just to get a count of people. I usually am throwing the ID number in the values, but the problem is ID numbers are often seen as numbers, and the default is to sum them up, and I get these outlandishly high numbers. So I change it to a count. Sometimes I'll put just a constant letter as a column, and you can use that as your counter. Your continuous variables, your marks, your SATs, well, you don't have SATs, sorry, your matric points, all those are things you analyze in the cells. You average them. You look for the minimum, the maximum, things like that. Let's see, this will look a lot cleaner. One thing I exhort my students all the time is show as few decimal places as you can get away with showing and still preserve the information. And this is for readability. So in this case, I don't have any small numbers below 10. So 2 decimal places no decimal places is fine. This is reasonable. Now, if numbers were really close and one is rounding up and one is rounding down, so they look like they're identical, that's where it could get a little crazy, but I could always look at the unrounded numbers. So this shows me that males are retained at a higher rate than females in AES, but in every other college, females have the slight advantage to males in the return rate. Is that significant? Is it meaningful? That's not, the data doesn't tell me that. I mean, honestly, I'm not surprised. From my 30 years of looking at higher ed data, I'm actually surprised there's not a bigger difference in health sciences. How does that differ by age? Let's get rid of the college. Well, those stupid age groups, because okay, I'm going to go through the process just for your sake and put that age back in here and get my 23 plus my new values grouped together. And when it does that, it loses, it just destroyed the entire grouping. So I have to actually do the grouping again if I want to. Actually, I think it has a little problem with it because sometimes it resorts to the old. I was going to do 20 to 22 and 23 and rest. And you could be playing while I'm doing this. It's all, have fun with it. Okay, now I can see that, I label. Nah, not much of a difference in retention by age. Well, overall there is, actually. I'm sorry, but not by gender and age. It doesn't interact, but yes, I'm sorry. So it's the 19-year-olds have the highest rate. Older students are significantly more likely to not return. Of course, I lost sight of the numbers. I don't have the numbers here anymore. I could throw in a variable to count the numbers, but then it makes it a little messy. I could put so at least I can see what I'm talking about. Yes, those older students are actually pretty significant in number. 2,000 in the first group, younger, older group, and 460 in the older group. So you guys got an issue with your older students that you should look at. I could see if that's in a particular college. Is it AES? Let's get rid of the counts. No, AES actually has the oldest group, is not bad at all. What about health sciences? Wow. The 23 plus students have a 39% retention rate in health sciences. So this kind of shows you how you play around with these things. You find these pockets. They used to be called leaky pockets. I can't remember who coined the term. It wasn't me. Although it's been so long, I can take credit for it. So there you got, and it's especially female older students in health sciences have a 23% persistence rate. In 1 year, you lose 77% of them. I think we should quit here and go find out what's happening. I mean, that's incredible. Okay, so play. And let me know if you need any help. 1 and 2. Now you just got the male and the female background, male and female. Does this work? Okay. Now you just have the male and the females, right? And the reason I said to have 2 was if you right-click on this one, you can summarize, show values as percent of column total. And then this one is now your percent. Females. Well, right now it's not by college. Right now it's overall. You'd have to put the college variable back in the columns to get that. They are. Okay, that's where that filter box. So you put a variable in there, like put college in there.
Okay.
And now, if you go up to 1, now you've got the drop down. So it's considered a filter because now you can do it for the different colleges. Wait, there was a question here. No. When you don't have parents, this is only one variable. It's not nested. Then you should do it of the column total.
Of the column.
It's only when it's nested.
Oh, okay. And then another thing is, when we lost it on the part of the pivot chart.
Okay. Well, turn those back into values so they look